Hello, everybody. How's it going? Mic should be good. We are good to go. So today, we're gonna hopefully make it through 1, 2, 3, 4, 5 sections. Okay, these three took me 2.5 hours. As did, how many were in here? 1, 2, 3, 4, 5. Okay, this one also took me 2.5 hours. So maybe it's possible. We'll see. I'm doubtful, but we'll see. Hopefully, okay, this one's pretty short. We should be good. We'll make it through all 5. Anyways, I hope everyone is doing all right. This is my continuation of learning Vulkan, and I'm excited to get back into it. In the last one, what we did was we set up a bunch of more queue families and all that good stuff. Still Tree, hey, how's it going? Good to see you. Oh yeah, we also turned off the verbose messages, which was nice. So now we get an actual reasonable number of messages here, which makes sense. But yeah, hope you're doing all right, Tree. So one other thing that I'd like to mention too is with the math animation thing, I am continuing to make progress. I've been saying this for the past 2 months, but I promise I'm actually nearing the end of this. Getting 3D stuff working good. I am fixing the text animations and stuff. You can see the layout's a little bit broken right now, but yeah, we got that. I also have this SVG cache. I don't know why I didn't display this here way long ago, but if I press Control, I can sort of check it. And this is basically the cache. So this gets dynamically updated with whatever we're caching from Nano VG, and there will potentially be multiple textures here and stuff. But yeah, I was basically just getting fonts working again. They work better than they did before now. You'll see if I switch this to random fonts, we get them working for the most part. They look a little bit strange to me. I'm going to have to look into it and see if these are correct. And then you'll notice there's also these rendering glitches. So there are still some things that I'm kind of working through, trying to get working correctly. But for the most part, it's looking pretty good. Yeah. That's turning out good so far, but today is going to be about Vulkan, so we'll get into that very shortly. All right, so graphics pipeline basics. I've done the graphics pipeline a few times, not like Vulkan, but I'm familiar with these concepts, so hopefully we can skim through this and get through this pretty quickly, depending on how intricate this stuff is. Anyways, so over the course of the next few chapters, setting up graphics pipeline that's configured to draw the triangle. Yep. So we take the vertex index buffer to an input assembler. It's the first time I've seen this mentioned. So usually I start with the vertex shader stage in OpenGL. That's what they usually start with, at least. Tessellation, you got geometry shaders, rasterization, and then fragment shader and color blending. And I'm guessing the green ones are the required stages and the orange ones are all optional, which is interesting that the vertex and the fragment are optional here. So the input assembler collects the raw vertex data. Okay, vertex shader runs for the, tessellation shaders, you can subdivide geometry. Geometry shaders, you can output more primitives. Rasterization, turns those into fragments. Oh, or no, I'm guessing the green ones are the non-programmable stages. That makes more sense. Okay, so orange is programmable stages, green is non-programmable. Color blending applies, and then the fragment shader, all that stuff. Stages with the green color is known as fixed function stages. These stages allow you to tweak their operations using parameters, but the way they work is predefined. And then stages with other orange are programmable, which means you upload your own shaders. So if you've used APIs like OpenGL and D3D before, then you'll be used to being able to change any pipeline settings with GL blend func. The graphics pipeline in Vulkan is almost completely immutable. Cool. So you must recreate the pipeline from scratch if you want to change shaders, bind different frame buffers, or change the blend function. The disadvantage is that you'll have to create a number of pipelines that represent all of the different combinations of states you want to use in your rendering operations. However, because of all the operations you'll be doing in the pipeline are known in advance, the driver can optimize for it much better. Interesting. Some of the programmable stages are optional based on what you intend to do. Yeah, that makes sense. Okay, in the next chapter, we'll create the first two programmable stages. Vertex and fragment shader. Yup. Create a... Okay, the final part of setting up the graphics pipeline, specification of input and output frame buffers. Create graphics pipeline function. It's called right after create image views and in init Vulkan, and we'll work on this function in the following chapters. Okay, cool. So this is interesting. And Tinspin, you saw my post on Hacker News today, did you? Yeah. There was a question on Hacker News that was like, is anybody still using C++? And I was like, yeah, I use it for my stuff. So interesting. It's good to see that you guys are on there too. So it's always funny when I see somebody that I suspect is somebody I work with too. I don't know if you guys have that, but you like see them and you're like, oh, TB, why pain? Very verbose. That's why pain. I like that Vulkan gives you so much functionality. I feel like we're missing a medium layer though, which I guess I could probably get with some library or something. But I feel like Vulkan, there's no reason I should be doing so much of this stuff. The extension loading, all that stuff. I feel like that's overly verbose. I feel like they should give you the option to do that, but then they should also give you the option to use some predefined function that's just like, hey, create Q family. And then you give it like some enum that's like, I want my, what are they even called? My graphics family, right? Or my present family. And then that basically does a lot of this stuff that we're doing ourselves, just does that itself. But then you can also just reach down a little bit lower level if you want to. DirectX 11 is kind of medium, but then Data and Windows Xbox only. Yeah. I think we'll probably see something like that if Vulkan is going to be the future. I don't see people continuing to write this low level of code. Like there's got to be something in between OpenGL and this verbose, you know. It doesn't feel like it should just be that or that, you know. They're two extremes, I feel like. But yeah. And Tinspin, to me, more rendering always increases motion to photon, and I really like my responsive gameplay. Questionable how much this level of control will help programmers in this way. I was so in regards to that and stuff too, I was looking through some old code, and I have a gist from a while ago. Let's actually do gist.github.com/AmbrosioGabe. Yeah, so this was actually not this one. This one was something I did for YouTube, for benchmarking the lookup, or this was like for the recipes and stuff. I made a whole video on this and everything, like why Big O is not a performance indicator, all that stuff. But what I found very surprising is the hash set for C++. Now, this is 1 nanosecond on average because of it's caching the results clearly. Like there's no way it's running in 1 nanosecond. But the maximum time is also interesting. So if I go down, so for 1 million elements in a set, looking up an individual element in a hash set in C++, the maximum time out of 10,000 runs, where is it? So this was average time, max time. Okay, yeah, 17.7 nanoseconds, which, like, it's not indicative of anything in general, but this is just like so fast. And the fact that we can get non-trivial algorithms like a hash set lookup, it's not hard, but it's not trivial either. And the fact that that runs in 17 nanoseconds, 20 nanoseconds, that's just, it blows my mind. So yeah, I don't think we need very low level of control for responsive gameplay. I think programmers just don't program very well these days, unfortunately. Casey Muratori's ref term lecture, I think, goes over that pretty good. Let's create this function very quickly, though. Create graphics pipeline, and we're going to put it... Man, I really want to start abstracting this stuff into separate files, which we will do after I finish this. I understand why I wouldn't want to do it now, because I don't want to make stupid abstractions, but still, this is like so many things. Okay, so we have our create graphics pipeline, which we're going to do here. Create graphics pipeline. Okay, and then we'll go create image views. right there, and we will put this here. All right, look at that. We've already done the first section. How about that, right? That's pretty good, as Zoding Daily would say. And actually, let's go, because I do have to add this here. There we go. One other idea I've been toying around with too is, I don't know if you guys have been watching that Lex Fridman podcast with John Carmack, but if you haven't, I've mentioned it before and I will mention it again. You should watch it. It's very good. But, and I might have mentioned this in the last stream too. He talks about coding games in assembly, and him and John Romero and Tom Hall would code a game a month in assembly. And I'm assuming this was like 6502 assembly. And I've been really kind of toying around with the idea of like creating a 6502 emulator and some sort of like wrapper where it gives you kind of the same atmosphere, just to see what I could come up with in those types of restrictions. First of all, making the emulator would be just kind of like a fun project, and I think it'd be interesting. I know Pico 8 engine, I think that's what it's called, does sort of the similar thing, but I think that would be pretty cool. And Tinspin, yes, but if you have multiple CPU cores collaborating on one frame, it will be delayed. My worst case scenario has been The Last Guardian on PS4. I filmed it and it had like 14 frames of latency. Unplayable. Oof. I am interested too. So The Last Guardian. I am not familiar with this game, but I'm just interested in the level of quality. Yeah. Okay. So you say 14 frames per second, which isn't great, but like, could you imagine just being even 2008, you know, when we just had, I think Cars, Pixar film, was released in 2008, right? Could you imagine a video game with this quality, which is pretty insane. It's an interesting, I don't think anybody could have been like, oh yeah, we're going to have that in just like 10 years running at 60 frames per second on like a home console. So it's still amazing what we can accomplish now. But no, I agree. You shouldn't have those types of problems. Okay, let's get an idea of how long these sections are. Okay, this is a long section. Shader modules. Let's do this. All right, speed running this section. Unlike earlier API, shader code in Vulkan, and he did ICO Shadow of the Colossus in this. All super duper good games, but the last two released with perf problems. Huh. Interesting. I'm interested too if he did it, if he used an engine or if he coded them himself. That'd interesting to know. I'm sure you probably will inform me, which would be cool. Unlike earlier API, shader code in Vulkan has to be specified in a bytecode format as opposed to human readable syntax like GLSL and HLSL. SPIR-V, and it's designed to be used with Vulkan and OpenCL, which I guess that's compute language or compute library, both Kronos APIs. And PlayStation Internal Studio, so Sony Engine. Gotcha. Yeah. Just insane. PlayStation blows my mind too. I really want to get a PS5 because their games look really fun. And yeah, I just watched Uncharted, by the way, too, which was actually a pretty good movie with Tom Holland. I couldn't remember anything about the movie, but it was fun to watch. So if you have Netflix and it's available in your region, you should check it out. Okay, so it's a format that can be used to write graphics and compute shaders. So yes, this is shader bytecode. The advantage of using bytecode format is that the compilers written by GPU vendors can turn the shader code into native code, are significantly less complex. Yes, makes sense. Yeah, okay, so basically bytecode is better because it's a stricter format, which means you have less wiggle room, is what I'm assuming this is. So however, we do not need to write this bytecode by hand. Kronos has released their own vendor-independent compiler that compiles GLSL to SPIR-V. Nice. This compiler is designed to verify that your shaded code is fully standards compliant and produces one SPIR-V binary that you can ship with your program. I've also heard that SPIR-V is like useful because it helps them obfuscate exactly what their shaders are and everything. Boy Bay Killer, how's it going? You have the GL object label tab open for at least 2 weeks now. I've had this open much longer than that, I assure you. This has been open since like October of last year, probably. But yeah, I have a bad problem with opening tabs and then being afraid that I'm going to lose it. I've got all these bookmarks too, and I've been trying to get better about just closing stuff that I've had open, but yeah. Good eye though. We'll have to bookmark some of these things so that I'm not just leaving them open all the time. I did just rebuild my PC. I think I talked about this too, though. So all the tabs aren't killing my computer anymore, which is nice. Yeah, 36, 28. That's good. And then even better is the temperatures, which I am very happy with, because before it was idling at like 60 degrees Celsius, which was horrible. But now it is, if we just launch this guy. Yeah, now it's definitely not idling. I'm doing a bunch of stuff, but it's just sitting at 40 degrees Celsius, which is so much nicer. It's where it should be, and my fans aren't going crazy all the time, which is awesome. It's amazing what a little bit of airflow can do for your computer. If you lose a tab, just press Control-Shift-T. Yeah, is that the, that might be a Chrome shortcut. Oh, no, cool. That's an Opera shortcut, too. I know one of them, like, restores your old window with all the tabs. I can't remember what shortcut that is, though. I think that's also Control-Shift-T, but I'm not sure. Okay, so SPIR-V bytecode, shader bytecode. So we can use GLSL-C to compile GLSL-lang, so the validator, and then we can use that. The advantage of GLSL-C is that it uses the same parameter format as well-known compilers like GCC and Clang, and includes some extra functionality like includes. Both of them, oh, cool. Both of them are already included in the Vulkan SDK, so you don't need to download anything extra. Yep. So I should have that available if I look where I installed Vulkan, which is right here, and I should have GLSL-C, which I do. Great. Okay. GLSL is shading language. Yep, we know all this stuff. As the previous chapter mentioned, we need vertex, shader, and fragment shader. Yep. Okay, I'm just going to kind of skip through this stuff because let's see what it talks about. So we've got that. They're hard coding the positions in here. Okay, and then they're using GL vertex index. Interesting. And I'm assuming that's just so that we don't have to deal with vertex buffers, which, yeah, I'm guessing that's exactly what this is. So yeah. And then the fragment shader is very similar. Seeing if there's anything like specifically interesting about this stuff. Okay, so compiling the shaders. This is where it's going to get a little bit more complicated. So I'm going to create an assets directory, and then we'll have shaders, and then we'll have shaders bin. Maybe I'll change that. I don't know. Like, should I have shaders and then bin in here, or should I have shaders and shaders bin? I should probably have, I don't like this, having this deep nested whatever. Okay, anyways. So we're going to have shader.vert. Let's go ahead and do that. Nope, got that wrong. Shader.vert without an apostrophe there. And let's open that with code, and we'll go ahead and just copy paste because this isn't complex. I'm not gonna waste my time going through this stuff. Yep. Oh good, they don't use a vertex buffer here. That's why I don't like this tutorial. Oh wait, oh no, that's, oh god, they don't use a vertex buffer here. So I don't like this tutorial. Nothing wrong with this. Sorry if you hear a motorcycle. I guess that's one of my neighbors. But nothing wrong with this, I don't think. I mean, it's a good way to skip that specific portion, which in Vulkan, everything is so verbose. I don't mind that they're cutting a little bit of stuff out for me. Okay, so we got that. And then we're going to have shader.frag, which we will just put in here as well. Easy. And copy paste that too. So yeah, what's this doing? We've got our positions 0, minus 0.5, 0.5, 0.5, and then minus 0.5, 0.5. Wait a second. 0 minus 0.5. This is like backwards to me. I expect this one to be first. So if we had a triangle, wait a second, I just gotta map this out because this feels backwards to me. So if we've got that, and that, right? This would be minus, I guess yeah, this is really weird. Okay, so what I would expect is minus 0. That's in the middle, 0, and then that would be positive, and then positive 0. I like that better. I don't know about you guys, but the way they had that seemed backwards to me. Okay, so anyways, just clear that out. What they've got is they've got the vertices there. This will just use whatever vertex index. This is like a shader variable that's available, kind of like GL position, which we're setting here, right? And then the colors, which we basically do the same way. And then we just put that inside of our frag color. And we take that in, and then we also output our color. Cool. So that's, yeah, nothing too complicated there. Let me check chat real quick. Chico Ferreira, 23. Good to see you. I'm the neighbor. Yeah, you're the neighbor on the motorcycle. It took me a minute there. I'm going to have to raise a complaint then, because, man, you're out there at like midnight and stuff when I'm trying to sleep and I hear a motorcycle out there. So no more midnight at least, okay? We'll make a deal. We're now going to compile these into SPIR-V bytecode using the GLSLC program. So we're going to create a compile.bat with all of that stuff. Cool. Let's go ahead and compile.bat. I like how they're assuming you're using Windows here too. Wait, that meant to say yes. Compile.bat, yes. And you'll try not to? Cool. I appreciate it. Okay, yeah, so we just do GLSLC, and I think I have this in... Yeah, okay, so I have this attached to my environment variable, so I'm not going to bother prepending it like that. Hopefully that makes it a little bit more accessible too, so other people don't have to worry about that. So we'll just say GLSLC shader.vert -o, and I'm gonna do bin/shader.spurv. What did he say? SPV, yeah. And he called that vert. And then we'll say same thing, bin/frag.spv. Okay, so if we do that, and we got a pause at the end, which is nice, so we can just click it and wait for the results. Okay, so looks like that worked fine. It did indeed work fine. And if we take a look at these, let's take a look in here. All right, cool. So you see we've got some prepended stuff, and then it looks like we've got the version there. So GLSL stood for 50. We've got a main function, Google CPP style line directive, include directive too. Yeah, so this is interesting. And I'm assuming these are just like the bytecode instructions and stuff. Yeah, this is one of the reasons I want to dabble in a 6502 emulator, because I like bytecode and stuff. I think it's cool. Can you try to use GL Vertex ID instead, which is the OpenGL equivalent? Sure, we can try that out. What did we use in here? We used GL Vertex Index. Interesting. So if we do that, does it still know what we're talking about here? Good question too. I didn't even realize that was, okay, it looks like we can't. Yeah, I didn't even realize that that wasn't the GL version, but interesting that it is different. And if we compile again, we're good there. Yeah, cool. And what if you had the top hash extension GL KHR Vulkan GLSL require? So that's going to be like, does it matter? So I'm assuming once it gets compiled to the SPIR-V, we don't, does it matter about the extensions at that point? That's what I'm curious about, but I can try that. I might have to put that below the version is what I'm guessing. We get extension not supported. Interesting. I wonder if that's just because we're using the Vulkan compiler. So I don't know if like that's just implied. I have no idea, honestly. I haven't worked with extensions and shaders and stuff. I usually just use whatever the default is. Oh, okay, and they're not assuming you're using Windows. They said Windows here, so that makes sense. Okay, so these two commands, yep, tell it to read it. If your shader contains a syntax error, yep. Compiling shaders on the command line is one of the most straightforward options, and it's the one that we'll use. Cool. It's possible to compile shaders directly from your own code. The Vulkan SDK includes libshaderc, which is a library to compile GLSL code to SPIR-V from within your program. Interesting. Yeah, this would be interesting to experiment with too, but I see why they're not doing that. Loading a shader. So now that we have a way of producing the SPIR-V shaders, it's time to load them into our program and plug them into the graphics pipeline. We'll first write a simple helper function to load the binary data from the files. I do not like that. That's not cool to me. I don't know. Stud vector char read file. I don't like that. Okay. The read file function will read all the bytes. We start opening the file with two flags. 8, start reading at the end of the file. Yeah, I'm just going to use like C style stuff there. Read the binaries file. Okay. Yeah, I'm just going to use my own. And this is where I will start adding some helper functions because I don't like all this code just being shoved into one file. So we'll call this file.h. Maybe I'll change it at some point. I don't know. So this is vk begins file h. And we'll have namespace vk begins. Or wait, no, I'm not doing namespaces here. I'm doing more C style, which means it's going to look like that, VKB. So we're going to have VKB file read. Yeah, I think that works. Yeah, because file is the namespace. Okay, so a file read, and then this will take in this will return char star. I don't know if I want to return a char star. We'll have a void. Yeah, what we'll do is we'll do a void, and then this will take in a const char star file name, and then it'll take in a char star buffer size t buffer size. And then what we'll do, I don't know, I don't like doing that. This is my own function. It doesn't matter too much. Okay, we'll do that. That, and then we'll just have void vkb file free. And that should free the contents. Cool. So simple enough. Let's do that. This will be file.cpp. I'm also purposely having a very flat structure here because I want this to be like C style. And I guess a C style project would have a flatter project structure. I don't know. I might add folders and stuff because that's not too big of a deal. Okay, so this would just be Vulkan begins /file. Yeah. And for this, we'll just say file star fp equals f open file name, and we need to say include std.io. We want to read binary. Then we'll just get the size of the file. So we can say size t, file size equals 0, fseek. We give it the pointer. Offset is seek end. Something like that. I don't know. I think it might be 0. I always forget the syntax for this every single time. Okay. C, read file. Every single time. Let's see. I just want to... Let's do this. Nope. Nope. Oh, man. Okay. fseek. Okay, here we go. So I guess we just do like seek set. Yeah, I think that's what we do. Oh, and then that's, wait, okay. I always forget how this stuff works. I don't know. I probably shouldn't because it's such a simple thing, but I do. Let me just look at my other code because this is easier than going through all this stuff. Let's go here, open, and then I'll go into here. That, and I should have something in here. Deserialize. Okay, this is what I was looking for. So it's 0 seek end, which makes no sense to me. And then 0 seek set. Yeah. Okay, whatever. So if I go back into here, what we want is offset is 0, origin is seek end, and then seek set means beginning, I guess. And then we can say size t file size equals ftell. And now we should be good. And then we can say fseek. There. Okay. Correct? Correct. Cool. That's all we need. Wojak2121. Why do you use include guards instead of pragma once? I had a friend who was using a different compiler, and the pragma once, it gave him warnings. So I was like, it's not a big deal to just do regular, you know, include guards. So I've just resorted to doing this, and not a big deal in my opinion. I mean, if you use pragma once, it's widely supported. You shouldn't really have problems, but if you use this, it's supported everywhere. You definitely won't have problems. So better safe than sorry, and it takes like 2 seconds. So yeah. Boy Bay Killer. Now I understand. GLKHR Vulkan GLSL TXT is implicitly enabled when using Vulkan, and does the exact opposite thing I thought. It maps some GL syntax to new Vulkan syntax, vertex ID to vertex index. Okay, interesting. Yeah. I was wondering where you were going with that tangent, but it makes sense. I'm not used to, so I'm guessing that you usually have to do the Vulkan, require Vulkan syntax or whatever when you're doing SPIR-V compilation for OpenGL is what I'm guessing. But yeah, interesting. So we get the file size. We're back at the beginning. We can say fread buffer, which is our buffer. Or I guess we could say that's our results. File size 1 FP. And so char star result equals, and we will go and include that, which is my helper. Size of char should be 1, but I do that anyways. And we do that. And then, and actually I'm gonna change this up a bit. Why use this? Where the size stood int. That's where we get these, isn't it? It is. I don't like that though. So gonna do this, which should be fine. Okay, so we'll do that. Uint 8. Okay, that's actually gonna be uint 8. Not a big deal. It's the same thing, but it is what it is. Turn result. Right, okay, so we read it. We also want to fclose that file pointer, and then if glogger error, null, and then right here, we can just say out of RAM, which is what that would probably mean. If you can't allocate memory, that's not good, no matter what's happening there. So yeah, I guess we don't really have to do anything. We just wouldn't want to read the file, but we can just let it return the result since it's gonna be null pointer anyways. So that should be fine. And then what we can do here is that, I don't think I should have a problem. If it's null pointer, what happens here? Okay, yeah, that is going to be a problem. So I have some stuff in here to do. Like basically this is all it does in release mode, but in debug mode when I'm tracking stuff, I have some extra plumbing there. I should probably add this to my library instead of having to do this, but we'll just do this. Easy enough. If it's not null pointer, we free it. Okay, cool. So we got that. That's what I'm going to use instead of what he's doing here, which is fine. So we'll go to create graphics pipeline. Go down there and we'll say uint 8 star, shader bytecode, or I guess, and that's just going to be file, or I guess VKB file read, and we're going to give it assets / bin / actually /shader / bin. I think it was shaders. And that should be good. And we'll have the same thing for fragment. And just to make these line up nice, vert and frag, which is what I think we had there. And let's go ahead, include Vulkan begins / file. And that's all good. And then of course we just want to free. Should be fine if it fails, or if it doesn't, we should be fine either way. And it looks like I didn't change those definitions here. So change that and that, and we are good. Cool. Let's just make sure this works right. I'll put a breakpoint there. We'll make sure that looks okay. Boy Bay Killer. The require thing is just normal GLSL extension enabling behavior. You can do that in OpenGL too. Just saw the extension somewhere, but never could test it because I don't have any Vulkan projects. So you had to test it for me. Okay, yeah. Glad to have tested it and glad it was working all right. Let's see if this is correct. I'm kind of looking over here. You guys should be able to see it now. If you look over here, I'll scroll up a little bit more. You can see we have GLSL stood 450, and then you can see main. So it looks like we are correctly getting our files read. And if we do that, it just cleared that memory for us, which is another thing I have in my memory manager. It should clear the memory whenever it's done being used. But yeah, cool. So that worked out good. Make sure that the shaders are loaded correctly by printing the size. Yeah, we just did. So they're correctly loaded. Before we can pass the code to the pipeline, we have to wrap it in a VK shader module object. Let's create a helper function, create shader module to do that. Cool. So create graphics pipeline. And then here, I'm going to do this. I should probably start separating these shader functions. That would be good. Main functions, and then yeah, I should probably group these two. I'll do that at some point. For now, it's all good. So VK shader module. So we do that, create shader module, const char star, shader code or shader source, and then we'll have a size t size. Ooh, and that's another thing. So when you're doing this, you probably want like how big this is. So we'll have data, and then we'll have 32 size. Yeah, and this will actually return that instead, because that's probably a better thing to do. And then we can just do that. Technically it's not const, so we'll leave it this way. If I wanted to be really C, I would do that, but I don't like that, so we're leaving it this way. Okay, so let's change these up. This should return file contents. And this should take in a file contents ref. Oh, and I actually named it file contents there too. Cool. So dot data, and then we'll do this dot data, and we'll also say file contents dot data equals null, and here we'll say that is 0. So we zero everything out. Right here, what we'll return is file contents, and we'll give it a null pointer in 0 size. Same thing here, well, actually, we can just do that and file size. And what we can do also, I'm going to cast that. We can also just go here, and if this happens, we'll just say file size equals 0. Okay, so that should wrap all that stuff up. And now, instead of doing this, excuse me, man, I'm gonna get some water real quick. Okay, so here we can just take in a file contents. I guess technically if I'm doing this true C style as well, this should probably be VKB file contents. You know, let's do that. We're gonna be good. If I'm gonna code this style, I should do it correctly and not get this stuff polluting the global namespace. So we'll just do that, that, and we should be good. And there we go. We are now good. And let's go ahead, create graphics pipeline. Let's go down there. So right below here, we'll have that. And this is the beginning of our shader functions. Okay. Do a little bit of that thing. Okay, cool. What's the reason you were setting everything to 0 when freeing? I do that just because you don't want garbage data in your memory. So I already do a couple things to help prevent memory type of errors with my allocation library. So like you'll notice I use this gmemory allocate, which if we drill into it, it does a little bit more than just allocating. It actually allocates some extra stuff and then it puts a flag there. So if we actually take a look, if I go and place this here, and we fix this stuff, this is just a VKB file contents instead, as is that. Okay, so if we jump back into there, yeah, so if we take a look at this result, what you'll see is actually, or you should see, I'm not seeing it there, which is a little bit concerning. Oh, no, we're not seeing it because I don't have it turned on. Okay, so if I go ahead and I turn on gmemory, I think I have to turn something on here. No. Oh, it's because of the padding. Okay. So I have this buffer padding, right? Right now it's set to 5. If we set that to something like 1024, what this is going to do is it's going to allocate extra bytes before and after every memory allocation that has a canary, which is a flag that tells me if something's wrong or not. So if we look up here, okay, now you can see it. Hopefully you guys can read it. It's a little bit small, but it says, "Hey Gabe!" exclamation point a bunch of times before and after our memory that we just allocated. And so what's happening there is basically if I do a buffer overrun, then when I free the memory, I check and make sure that these are all the same. If I find one of these characters has changed, then I know that there's been a buffer overrun for sure, and I can print out an error. So this helps prevent me from doing stuff like if I were to go result file size +1 equals like Z, right? I just randomly change some stuff. And we'll also do this for now. Normally, like in Java, this would throw an error, but since we're in C++, this isn't going to tell us anything. But because I have those flags there, when we free that memory, I'm going to get a warning, and it says heap corruption detected, buffer overrun in memory allocated from, and then it tells me the file and the line number that I allocated it from. So we know that line 19, which is where I just allocated this, there's been some sort of buffer corruption. And so basically zeroing out the memory helps prevent errors like this, because what can end up happening is in C++, if you have some memory that has some garbage data in there, shouldn't that do a seg fault? No, it's not going to do a seg fault unless it's on a page boundary. So the way that the OS operates is you can't actually allocate in blocks smaller than like 512 kilobytes. I think that's the default page size. So you can actually overwrite memory up to a certain point, and the operating system won't notice anything unless you're on a boundary where the page you overwrite into a page that you don't own, and then the OS will segfault. So that's why segfaults only happen sometimes. But yeah, and so then the reason I zero things out is because zeroed memory is automatically treated as null pointer, and it should indicate that there's something wrong. Whereas if I have garbage data and I accidentally read that data back, I don't know if that's real data that's just messed up, or if it's garbage data that I'm reading out of bounds of memory or something. So 0 is a good indicator that, hey, this is not right. I don't think I zero memory on free though. No, I do not zero memory on free. So I do just free the memory, but it is good for all those things. So yeah, and it's a force of habit. So once I do this, I know it should be 0 and everything. But yeah, good questions. Things that I've run into, and people make it sound like it's harder to catch these things than it should be, but you can code up some stuff like this stuff is not that long. Okay, so it's 1,200 lines of code, and this is just the Sean Barrett license, which I just copied and pasted. But a lot of this is also just documentation and stuff. It's really not that hard to write code that tracks these things for you. So yeah, I would definitely say give it a try if you're ever curious and stuff. The actual code that tracks the memory and everything is just this. So like a couple hundred lines of code, and you get all this stuff for free, which is pretty cool. But yeah, okay, so we've got those file contents. We're passing those through to there. This function will take a buffer with bytecode. Is that in a repository or something so I can take a closer look later? Yeah. I would not consider it completely safe. I don't know. I've used this quite a bit and I haven't run into any problems with it, but use at your own risk is basically what I'm saying. So you can check it out there though, and it should be operating system independent. I think I have it set up to work on Windows and Linux. So you should be fine if you're on either of those systems. Yeah, I'm pretty sure. I'm not completely sure, but I'm like 90% sure. So should be good. Okay. So function with bytecode as a parameter, VK shader module from it. Creating shader is simple. Famous last words. We only need to specify a pointer to the buffer with the bytecode. And yeah, no problem. We only need to specify a pointer to the buffer, the bytecode, and the length of it. This information is specified there. The one catch is that the size of the bytecode is specified in bytes, but the bytecode pointer is a 32T rather than a char. That makes sense, though. I would actually expect that to be 64, so kind of interesting. Therefore, we'll need to cast the pointer with reinterpret cast as shown below. When you perform a cast like this, you also need to ensure that the data satisfies the alignment requirements of uint32t. Lucky for us, the data is stored in a vector where the default allocator already ensures that the data satisfies the worst case alignment requirements. What's the default allocator? I think the default allocator is just malloc, right? Let's see. Is the default CPP allocator malloc? Yeah, basically just calls new. Okay. Yeah, I'm sorry. I had to look into that because he makes it sound like it's going to do something special. But I don't believe stood vector is going to like do any sort of aligning or whatever. Like it's going to be aligned on an 8-byte boundary, I think. And so I don't know, maybe the reinterpret cast here does something. I don't know why he points that out. Maybe somebody with more information can tell me though, or somebody smarter than me could be like, oh yeah, malloc is actually not going to make sure this happens too. I think this should be fine though. Okay, so anyways, we create the create info, give it the size and the code. Okay, so let's do that. If we have problems, I'll put a to do in here just to remind myself. So VK shader module create info equals 0 initialize dot type equals s type VK type. It's something like that, right? Structure. Oh yeah, VK structure. So S is structure. Shader module. So it's a structure type shader module create info. Believe that's what we needed, right? Cool, that's correct. Create info dot code size equals that, and this is size T. Okay, and we're giving it a uint32. That should be fine. Create info dot p code, which is a uint32t star, which I believe we should be fine just doing that, and we should be good there. Yep. Like the only thing I could think of is if this doesn't end on a 32-byte boundary, we would have to increase our allocation to be a few bytes bigger to account for that. But I think that's it. I think that's all doing that would do. Or at least that's all that. Did they do like a vector? No, they did a vector of char. So yeah, I don't know what they're going on about there. Okay, so then we get the shader module. We give it the create info, and then we return the shader module. Cool, that is easy. So that actually was cool. If VK shader, actually I'll just do uint32 result equals VK shader create VK create shader module. We'll give it the device, which I'm guessing is our logical device, our create info, our allocator, and our shader module, which is our module. So then, or I guess we'll call it that, VK shader module, do that. We'll return that. G logger assert result equals VK success. Or I guess we could do a if not result that failed to create shader module. Just do that. Okay. Tree, the compiler will make sure that all the structures, etc., will be properly aligned. So I guess that malloc or new will align it properly in memory. I think the way he wrote it is a little bit confusing for me. I think that way he wrote it is a little bit confusing for me. Yeah, me as well. I mean, like, just reread through this one more time real quick. So the one catch is that the size of the bytecode is specified in bytes. The bytecode is a uint32 pointer rather than a char pointer, which would be an 8-byte pointer. Or an 8-bit pointer, right? So that's just 1 byte, where this is 4 bytes. Therefore, we need a reinterpret cast. When you perform the cast, you'll need to ensure the data satisfies the alignment requirements of uint32t. Yeah, so like what are the alignment requirements of uint32? Is he saying that you need to make sure that it has a uint32 alignment, like it ends on a 4-byte boundary? It's basically what he makes it sound like where if you were like, you ended on a 31 bytes, you would want to increase that to 32 bytes to make sure that you're still that. But I don't see how this would do that unless reinterpret cast is allocating memory, which I do not believe it does. So yeah, it is just really weird the way he wrote that and everything. Okay, cool. Shader modules are just thin wrappers around the shader bytecode. Yep. The compilation linking doesn't happen until the graphics pipeline is created. That means that we're allowed to destroy the shader modules as soon as the pipeline creation is finished, which is why we'll make them local variables in the create graphics pipeline instead of class members. Interesting. Cool. So up here, we will have our VK shader module, vert module. We'll give it the bytecode, and then VK shader module, frag module. I actually do like this whole pipeline idea and making it mutable and everything. This appeals to me because I've been wishing for stuff like this. And I guess I could create abstractions in OpenGL to do the same stuff, which is exactly why I'm learning Vulkan in the first place, to get new ideas like this. So yeah, the cleanup should happen at the end of the function by calling VK destroy shader module. Cool. VK destroy shader module. Give it that vert module. Oh, and is it the logical device? I didn't even check, but I should. He just gives a device, which I imagine is the logical device because I think I renamed it that to be explicit. Okay. That vert module, null pointer, frag module, and we should be good there. The cleanup code, yep. So shader stage creation. To actually use the shaders, we'll need to assign them to a specific pipeline stage through pipeline shader stage create info structures as part of the actual pipeline creation process. Man, a mouthful. Okay, MSDN says that in C++ int is 4-byte aligned. Okay, so that makes sense. Like that int would be 4-byte aligned. Is char 4-byte aligned though? Let's see. Oh, wait, no, yeah, you're right. No, okay. I think basically what he's saying is that it just needs to be aligned on a 4-byte address, and that will happen no matter what. I believe. I think so. Maybe not. I don't know. Let's see these docs that you posted real quick. Okay, yeah, so char is on a 1-byte boundary. Yeah, so I imagine like what we would have to do then is something like that, and like basically say if the size and then we'd have to say something like bytecode.size equals that, whoops, and then zero out the extra memory, but I'm not sure if this is necessary. We'll put a and since bytecode is UN32, it is by default aligned to 4 bytes. Yeah. Okay, we'll go with that. We'll see what happens. If anything weird happens here, I guess we can just default to, maybe we should try that out, but I think you're right. I don't think we need to worry about that. To actually use the shaders, yep. We'll start by filling in the structure for the vertex shader in the create graphics pipeline function. So VK pipeline shader stage create info, which we'll have here, VK pipeline shader stage create info. What does he name it? Interested. Vert shade shader info. Vert. Wait, what did he call it? Vert shader stage info. We'll go with that. So S type is VK structure, vert, or I guess pipeline shader stage create info. And what is this? And we have the stage. Okay, so we set the stage to the vertex bit. And I'm guessing we'll do something similar for our fragment shader, and this will be our fragment bit. Yeah. The first step, besides the obligatory S-type member, is telling Vulkan which pipeline stage the shader is going to be used. There's an enum value for each of the programmable stages described in the previous chapter. Oh, yeah. So he's just talking about the vertex bit. And then we have to say the module is the vert shade module, and then the P name is main. So the next two members specify the shader module and the function to invoke, known as the entry point. That means it's possible to combine multiple fragment shaders into a single shader module and use different entry points to differentiate between their behaviors. In this case, we'll stick to the standard main, however. That's an interesting concept. So we'll say vert shader stage info dot p name equals main and module equals vert module. I believe that's what it was, right? Yeah. This is one more optional member, the specialization info, which we won't be using here, but it's worth discussing. It allows you to specify values for shader constants. You can use a single shader module where its behavior can be configured at pipeline creation by specifying different values for the constants. This is more efficient than configuring shader using variables at render time because the compiler can do optimizations. Cool. If you don't have any constants like that, then you can set the member to null, which our struct initialization does automatically. Interesting. So I wonder if that's for like constants in that shader stage, like constant uniforms, or if that's for constants like compile time constants, like if defined, use this thing type stuff. Yeah. And still tree. So I have no idea why he even mentions it all. Oh, I saw that comment earlier. So should be good. And modifying it for the fragment shader is easy. We've already done that bit mainly. Oh, and we should also change that. That would have been a headache. Dot module equals frag module. P name equals main. Nice. Okay, and then he also creates, that's all there is. Oh, and then finish by defining an array that contains two structs we'll use later to reference them. So shader stages. Well, why did we do this then? Why not just do that all at once? I don't know. Okay, whatever. So we'll say VK pipeline shader stages equals and that. Okay, so we'll do that. And I'm doing Java style. That should be over there. Okay. I wonder if, I think this is probably a better way to do this. Nah, this is fine. I was gonna like block this off into a separate scope and everything, but it really doesn't matter. Okay, we're on to the next one. Look at that, guys. We're 3 tutorials in, but this one looks big, so my confidence just went down. Okay, it's not too bad. Not too bad, and I think the conclusion will hopefully be easy too. Okay, so older graphics APIs provide a default state for most of the stages. In Vulkan, you have to be explicit about most pipeline states. In this chapter, we'll fill in all of the structures to configure these fixed function operations. Dynamic state. While most of the pipeline state needs to be baked into the pipeline state, a limited amount of the state can actually be changed without recreating the pipeline at draw time. Examples are the size of the viewport, line width, and blend constants. If you want to create dynamic state and keep these properties out, then you'll have to fill in dynamic state create info like this. Interesting. He doesn't mention the scissor. I'm guessing this is for like, what's it called? Like stencils and stuff. And he doesn't mention that. So I guess stencils are also dynamic state that you can change. Okay. This will cause the configuration of these variables to be ignored, and you'll be able and required to specify the data at drawing. This results in more flexible setup and is very common for like viewport and scissor state, which would result in more complex setup when being baked into the pipeline state. But I'm guessing we're just ignoring this for now. Vertex input. The input, vertex input, create info. VK pipeline vertex input state create info structure describes the format of the vertex data. Bindings, it describes this roughly in two ways. Bindings, spacing between the data and whether, okay, so that's like a VAO stuff. Yeah, attribute descriptions. Because we're hard coding the vertex data directly into the vertex shader, we'll fill in the structure to specify that there is no vertex data to load for now, and we'll get back to it in the vertex buffer chapter. Interesting. Please name the main shader function to something silly. Will do. We can call this, also, why is this not on a new line? That's not cool. Well, you guys are going to have to help me come up with a name. I'll name this one Still Tree since you were the one who suggested it. And then for this one, I have no idea. Vulkan Pain will be this one because that's what we're going through right now. Okay, let's go ahead and just change these up too to reflect that. And it better still work. It should still work. We'll be fine. I just have to recompile it. Let's get rid of that. Oh no, missing entry point. Do I have to mark it as an entry point? Name it cheese. The first thing that came to your mind. Mark function as entry point GLSL. We have to like tell it what it is and everything. Okay, we'll do this. We got this. So if we were to go into here, this is going to confuse me later on when I go to change it back to something else. Source entry point is what I call this Vulkan pane. And then we'll have this one be cheese. Okay, and then we'll change this to cheese. Let's see if that works. No, unsupported option. That's not cool. Maybe I'm just doing that in the wrong point. Let's do that right here. See if that works. Oh man, it just doesn't want us to do that. All right, we'll have to revisit this afterwards, but for now, we're gonna have to stick with main, unfortunately. So if we just change these back to main, it shouldn't complain anymore. Interesting to know though. I need to do experiments like this more often. When I follow tutorials, I just go through the tutorial as fast as I can so I can start doing other stuff, which probably isn't the best way to do it. But it is what it is. Okay, so the p-vertex binding descriptions and attribute descriptions point to an array of structs, describe and mention those, and this structure to the create graphics pipeline right after the stages. Okay, so we're gonna create our vertex input state create info. VK pipeline vertex input state create info vertex input, what does he call it? I am interested in the naming. Okay, vertex input info. So that was basically what I was going to go for. Okay, so we'll call it that. Let's just fix that stuff. Vertex input info.type, of course, is VK structure type pipeline vertex input state create info. I'm getting this naming stuff now. If you have an S type, all you need to set it to is structure type followed by that. Okay, makes sense. So we want to set, these should all be zeros anyways. Yeah, so we really don't have to do anything. I'll just copy this stuff because really it doesn't matter. Okay, so we got that. Input assembly. This struct describes two things: what kind of geometry will be drawn and if the primitive restart should be enabled. The former is specified in topology member and can have values like point list, line strip, line from every two vertices, point from vertices, end vertex of every line, triangle list, triangle from every three, The second and third vertex of every triangle are used as first two vertices of the next triangle. Interesting. Okay. Normally, I am just interested too if they have more than that, because yes, it looks like they do. Patch list. Interesting. Provoking vertex. Okay, so this is interesting stuff. I was just curious because I know in OpenGL you can have like certain signals and stuff that mean like restart my primitive, so that you can actually have several primitives in one batch. And I'm guessing that you can probably do something like that. And it's also called primitive restart for that. Normally the vertices are loaded from the vertex buffer in sequential order, but with an element buffer, yep, you can specify the indices yourself. This allows you to perform optimizations like reusing vertices. If you set the primitive restart enable to true, then it's possible to break up lines and triangles in the strip topology. Okay, yeah, so this is talking about it, where you use like some signifier and then it basically says restart to a new batch of triangle strips or something. We intend to draw the triangles throughout this tutorial, so we'll stick to the following data structure. So pipeline input assembly state create info. Pipeline VK pipeline VK pipeline. I cannot type today. Input state create info assembly state. This is bothering me too. Okay, that's better. So our assembly state info dot s type equals VK structure type assembly. No, is that not it? Oh, I'm missing pipeline. I was like, did they change the naming? No, they did not. I was just using the wrong thing. Okay, assembly input assembly state create info. Yep. Cool. And then the type, okay, so yeah, topology, we're using a triangle list, and primitive restart is off, which makes sense. Topology is VK triangle list. And then this guy, what was it? Topology and primitive restart is off. I just automatically defaulted to GL false instead of VK false because I'm so used to that. Yeah. Still tree. The parameter for custom entry point works only for HLSL. That's why I could use it in Direct3D 12 and not in Vulkan. Interesting. I feel like there's probably a way that I could get it to work too with the Vulkan validator or whatever, because it doesn't make sense. Like they even mentioned it in there that you could set several entry points, but maybe it does just need at least one main entry point for whatever reason. But it was weird. Viewports and scissors. A viewport basically describes the width and height. This will almost be 0, 0 width height, and the tutorial will also be that case. Yep. Okay, so we have a VK viewport. VK viewport. Do that. We want the X, Y, width, height, min depth, and max depth. X equals 0. 0. He said swap chain extent, which I guess that does make sense. Because now we're not thinking in terms of windows, we're thinking in terms of whatever our swap chain is. All right. Remember that the size of the swap chain and its images may differ from the width and height of the window. Yep. Swap chain images will be used as frame buffers later on, so we should stick to their size. Makes sense. The min depth and max depth values specify the range of the depth values to use. These values must be within 0 to 1, but min depth may be higher than max depth if you aren't. That's interesting. If you aren't doing anything special, then you should stick to the standard 0, 1. While viewports define the transformation, scissor rectangles define the region which pixels will actually be stored. Any pixels outside the scissor rectangles will be discarded. They function like a filter rather than transformation. The difference is illustrated below. Note that the left scissor rectangle is just one of many possibilities that would result in the image, as long as it's larger than the viewport. Yeah, okay. So that makes sense. It's basically just for like clipping, right? This is just like a clipping rectangle is what a scissor is. Which I guess you clip with scissors, right? So that makes sense. Okay, so if we wanted to draw the entire frame buffer, we'd want to specify a scissor rectangle that covers it entirely. Oh, I guess we are doing this dynamic state stuff. Interesting. I thought we were going to skip this, but looks like we are doing it. So let's set that up. R VK rect 2D scissor rect extent dot, okay, offset dot x equals 0, offset dot y equals 0, and then extent width equals swap chain extent dot width, height equals height. Alrighty. Oh, and they just said it. That makes sense too. Of course. That's easier. We could just do that and it should copy it, which is nice. Okay, so we can do that. And I'll also simplify this too, because it does make sense. Okay, so we do that, that. If only we had the C initializer list, that'd be cool. I guess it's not called an initializer list in C, but like where you can do like .x equals. C++ needs that, and I don't know why they haven't implemented it. It's probably because of some parsing ambiguity that they don't want to deal with, which is annoying, but whatever. Viewports and scissor rectangles, yep, they're dynamic. When opting for dynamic viewports and scissor rectangles, you need to enable the respective dynamic states for the pipeline, of course. And then you only need to specify their count at pipeline creation time. The actual viewports and scissor rectangles will then later be used drawing time. With dynamic state, it's possible to specify different viewports within a single command buffer. Without dynamic state, the viewport and scissor rectangle need to be set in the pipeline using this create info struct. This makes the viewport and scissor rectangle for this pipeline immutable. Any changes required to these values would require a new pipeline. Independent of how you set them, it's possible to use multiple viewports and scissor rectangles on some graphics cards. Okay, so we'll probably just do the static, and then I'll leave a note in there that we can do dynamic. So we'll just use this. VK pipeline viewport state create info. Is it viewport state create info? Yeah, okay. Call that. Note, this can also be set to be dynamic so that the pipeline does not need to be recreated when the viewport or scissor rect changes. I don't care about that for now though. Viewport info dot s type equals vk structure type pipeline viewport create info viewport state create info. Okay. One, and then we set it to that. Okay, yeah, that's simple enough. So viewport info dot viewport count equals that. And P scissors equals that. All right. The rasterizer takes the geometry that's shaped and turns it into fragments. It also performs depth testing and face culling and the scissor test, and it can be configured to output fragments that fill entire polygons or just the edges. All this is configured using rasterization state create info. Man, I should probably write down what's happening here too. So this is create the viewport stage. I don't know. This isn't even a stage though. Okay, so this is like create vertex shader and fragment shader stages. Yep, and then this is create the fragment. I don't know. This is like, I guess I'm just going to leave it as is. The code kind of tells you what's happening here. But I would like to break this up at some point into like different functions and stuff, since these are different things specifically. So pipeline rasterization state create info. So that S type is going to be VK structure type, pipeline rasterization state create info. And what do we want to include there? Just depth clamp enable. If depth clamp enable is set to true, the fragments that are beyond the near and far planes are clamped to them as opposed to discarding them. This is useful in some special cases like shadow maps. Using this requires enabling a GPU feature. Interesting. Okay, so that's false. Rasterizer discard. So if this is set to true, then geometry never passes through the rasterizer. This basically disables any output to the frame buffer. I guess that's useful if you just want to turn off certain stages or something. And it should be false anyways, by default. Chico Ferreira, VK pipeline rasterization state create info, and people complain about enterprise Java names. Yeah, I am with you on this one. I am definitely with you there. I can see what they were going for, like just to make it. I don't know. I feel like OpenGL had a pretty good, I don't know, OpenGL's got some pretty long stuff, but nothing like that. Like you have GL multi-draw arrays indirect. But yeah, that's still not, doesn't even compare to that. Man, I do not know why it's so verbose. Okay, let's see. Polygon mode determines how the fragments are generated. We can do fill, line, or point. Oh, that's kind of cool. Yeah, so that's pretty cool. So we could basically just turn on like wireframe mode by switching this up, which is interesting. Polygon mode equals VK polygon mode fill. Okay, and then line width, the thickness of the lines. The maximum line width is that dependent on the hardware, and any line thicker than 1 requires you to enable wide lines GPU feature. So the cull mode, back bit, and then front face clockwise. Okay, so that's pretty explanatory. VK cull mode, what was it? VK cull mode, back bit. So we cull the back faces. And what was the other thing called? Front face. Front face is clockwise direction. Okay. Depth bias enabled. Okay, so that's just that biasing. Okay, so yeah, you just add a constant value. So this is all for depth bias stuff. Okay, we'll just do that. If I can do this correctly, there we go. And multi-sampling. So the create info also configures multi-sampling, which is one of the ways to perform anti-aliasing. It works by combining the fragment shader results of multiple polygons that rasterize to the same pixel. This mainly occurs along edges, which is also where the most noticeable aliasing artifacts occur. Because it doesn't need to run the fragment shader multiple times if only one polygon maps to a pixel, it's significantly less expensive than simply rendering to a higher resolution and downscaling. Cool. It enables requiring a GPU feature. multi-sample create info. So VK multi-sample create info, VK pipeline multi-sample create info. Okay, there we go. Just call it that. And multi-sample info.type equals VK structure type pipeline multi-sample state create info. Oh, we'll revisit multi-sampling in later chapter. For now, let's keep it disabled. Oh, so we're not even enabling it. Okay, I'm just gonna copy this then if we're not even enabling it. Cool, so sample shading. Interesting. Well, if it's covered in a later chapter, I guess it doesn't really matter too much. If you're using a depth or stencil buffer, then you need to configure the depth and stencil tests too. We don't have one right now, so we can just pass a null pointer. That's good. Color blending, and then we have this too. After a fragment shader is returned to color, it needs to be combined with the color that's already in the frame buffer. Mix the old and new values, combine the old and new values. There are two types of structs to configure: the color blend attachment and the color blend state, which contains the global color blending settings. In our case, we only have one frame buffer. The first struct contains the configuration per attached frame buffer, and the second struct contains the global color. Okay. Color blend attachment state. Is this not create info? Oh, it's not a create info. Color blending. All right. No, color blend attachment is what he calls it. We'll do the same thing. So right mask, R, G, B, and A. And then the blend enable is false. Okay, so we're just turning it off. So color blend attachment dot. I thought that was like blend state or something. Oh, color right mask. Okay. VK color right mask or something? No. What was it called? VK color component. VK color component R bit RG. Okay, we're just gonna do this because this is probably the easiest way to do this. Okay. B and A. This is false. And then they set up these things, which are basically the same as OpenGL stuff. See, like, this is what I'm saying. OpenGL has this right? You just do GL blend func, S factor, D factor, VK blend factor. Like, why couldn't I just do that here too? And it like automatically does all these default things, and then I can add the extra stuff if I really want to. And Lord Talks is rating with a party of 7. Awesome. Thanks, Lord Talks. I hope I didn't miss that too long ago. I don't know when that exactly happened, but we're kind of in the middle of this stuff. So I keep losing focus. But yeah, like I don't get why Vulkan can't just do something like that and then we can just have a attachment. Just a few minutes, but you were in the zone. Okay, that's good. Yeah, I don't get why we can't just do that. That would be so much simpler. And then have all that stuff defaulted to reasonable values, and then you can change it later on if you want. It is interesting, though. Void, it's because you can't change that stuff after pipeline creation. Well, yeah, I get that you can't change it after pipeline creation, but like, why can't you just do like a VK create pipeline color attachment, and then just do blend factor 1, 0, and then it like uses sensible values or something, right? Because I imagine this will most likely always be RGBA. This will most likely always be add, but you can change it if you want. And then why is this declared twice? Source, dest. Okay, yeah. Oh, yeah. And then especially like these are probably going to be the same for most cases, you know, and then you could just have that. And then if you wanted to, you could say, that's my attachment. And then you could also go in and change the default values if you wanted to. And then that would allow you to do the same thing. Yeah, because I feel like that's what I'm going to end up doing anyways. The real reason is it's a C library, so there's no default constructor. Well, you don't need a constructor either. You could just have a function, which does that, and same thing. Yeah, the tech isn't there yet. I guess that's it. Yeah, because I've used plenty of libraries, C libraries too, that do allow you, well, yeah, I guess this is kind of the C way of doing things, isn't it? I mean, technically in C, you would just do like that, which I guess is a little bit nicer, and then you could like initialize stuff. I don't know. Yeah, I guess that makes sense. I guess I'm just complaining because there's so many settings, but I guess that's necessary too. Let's see. This per frame buffer struct allows you to configure the first way of color blending. The operations that will be performed are best demonstrated using this pseudocode. Yes. Okay. There's the auto-generated Vulkan C++ bindings, but I haven't investigated whether it generates a CTOR. That doesn't suck. Yeah, I imagine the constructor would probably be kind of scary too there. But that is interesting. Lord Talks, I'm interested too. So you just raided with a party of 7, and you seem to be knowledgeable about Vulkan. So I'm interested in what you are streaming about and stuff, if you're interested in sharing that. I'll have to go check out your VOD after this to see. So he's just kind of explaining what's happening here. Yeah, and then explain what's happening there as well. Streaming some Vue.js. Nice. I have not used Vue.js, but yeah. Vueoid, it generally sets the S type to the proper value and leaves everything at 0. I'm guessing that's about the generated bindings, but yeah. But you do graphics dev as a day job. Oh, that's super cool. I don't know if I'd want to do this as my day job. I'm happy having this as my hobby and then my day job being web dev because I consider that way easier than doing this stuff. So I get to do the easy stuff, and then when I want to have fun, I can dive into this stuff. So, but that's cool. Thanks for the raid and stuff too. I'll have to go see if you have some interesting streams where I can learn some stuff about the graphics side of this stuff. This can be accomplished in the following parameters. Okay, so he's just showing how you could do that. You can find all the possible operations here. The second structure is an array of structures for all the frame buffers and allows you to set blend constants that you can use. So the blend state create info. Okay, and then this is where we have our next thing. Yeah, and then we just set that to our color attachment. Okay, so let's do that real quick. VK pipeline. Blend state create info. Do that. Blend info.sttype. And you haven't done Vulkan in a project yet, but you've done real deep into DX12 and OGL. Nice. I'm not sure. Oh, OGL, OpenGL. I was going to say I'm not familiar with OGL, but yes, OpenGL is cool. Yeah, I haven't done any DirectX stuff. I'm doing this to kind of learn about different ideas and stuff, and OpenGL is a good... I do enjoy OpenGL API. So I've heard DirectX 12 is similar to Vulkan though, if you do some of the more low-level things. I think that's DX12. So it'd be interesting to see how it kind of compares and everything. But yeah, that's cool. Vulkan's cooler than DX12 anyway. I don't know. I don't know if I'd consider this cool so far, at least. Very verbose, but we'll see. I haven't done DX12, so I guess I can't speak on that. Okay, so we'll call this S-type, VK, structure, type, pipeline, color, blend, info. That's what we want. DX12 has constructors. That is true. DX12 and Vulkan are both like super verbose because you lose the driver thread. Yeah. And I am questioning whether it is worth it, at least right now. It's nice. I wish OpenGL, I was saying this at the beginning of the stream too. I feel like there needs to be an in-between Vulkan and OpenGL type thing where you have the immutability of like pipelines and stuff. Because I do like these ideas. These are awesome. And OpenGL has way too much global state, but I feel like this is too verbose for most people, including myself. I would much rather deal with global state stuff than this. But yeah. And yeah, but they're like old school Win32 API constructors. Metal? I have not used Metal, so I wouldn't be able to tell if that's in between or not. Yeah. Let's do blend info dot attachment count. Okay, so we've got one attachment. P attachments. Yep. And that's going to be our color blend attachment. Okay, so what were the logic ops he was using? So no logic op, but he sets it anyways to copy. I guess that's what we're doing too. So logic op enable false, but we'll set it anyways to logic op copy. And then the last things he sets are blend constants all to 0, which doesn't really matter, but I'll copy it. That and 1, 2, 3. Yeah, does it say? Is this like a sized array? It is. Okay. Cool. So we got that. If you want to use the second method of blending, bitwise combination. Okay, so that's just talking about that stuff. Finally, we get to pipeline layout. You can use uniform values and shaders. Oh, this isn't quite what I think. Okay, we're almost there. And then we get render passes, and I'm almost done with this section, which is great. These APIs are so verbose because most game engines end up wrapping them in their own helper classes, so they don't offer much in terms of friendliness. Yeah, and that's what... Yeah. I feel like that's, I guess, what OpenGL kind of does too, is essentially almost like wrapping these in helper classes. I'm wondering how similar each game engine ends up wrapping these. Because I'm really curious, like how much of these are they actually configuring to be super specific, and how much of these are like the same APIs just duplicated except like slight differences. And it'd be interesting to pull out that common functionality out of all the big game engines and have that be like the middleman. And then for the things that they tweak, leave those as like the programmable features. But I'm guessing the people who designed these specs and everything thought a lot about this. And so there's probably a lot of differences. I'm guessing they had a lot of experience, more experience than I do, for sure, with all that stuff. So, yeah. Okay, so. Yep. These uniform values need to be specified. Okay, so now we have our pipeline layout. We'll do that. How's it going, Voxriffs? Good to see you. He does not. Okay, he does. Wait, no, he does not zero initialize that. Oh, because we're going to pass that in, I'm guessing. So we'll do that. And that is not VL, that is VK. Pipeline create info, and we will zero initialize that. Okay, so then S-type, all that stuff. Gotta grab some dinner. Thanks again for the raid, Lord Talks. Good to see you. So, pipeline create info.S-type equals VK structure type. Pipeline create layout create info. This Voxrus, I know you've gone through this pain, so I think I remember when you were doing this stuff and talking about it and everything in the Discord, and now I understand finally. Colioli, I hope I said that right. Cat Jam. Is that a game jam that I'm not aware of? If so, nice. Yeah, these are all set to 0 initially, but I'm guessing we'll probably be using them later. So that's good enough for me. That, and then I'm guessing we call the VK create pipeline layout. Yes, of course we do. So I swear I just fixed all that, but maybe I didn't. Okay. So VK, we'll say uint32 result equals that logical device create info, which is that. We want to give it our allocator, which we're leaving null, and then that, which is that. If not, or I guess if result does not equal success, then we'll say assert false pipeline. All right. Cool. Structure also specifies push constant, which are another way of passing dynamic values. That's interesting. So that we may get in a future chapter. Pipeline layout will be referenced throughout the program's lifetime, so it should be destroyed at the end. So, oh, he said to make that as a class member. Whoops. Okay, so let's go up to our static variables up here. Okay, and I guess this is our pipeline stuff. So we will have this here, and then inside of free, we want to VK destroy pipeline layout logical device pipeline layout and null pointer. Let's make sure this all works. I should probably be doing this more often. Uh-oh, that's not good. It doesn't like our shaders. Did I forget to take something out of here? What do we get here? Failed to create shader module. That's all we got. What's the shader module look like? So that's, what's this look like? So that's the code. Let's just make sure this is right. GLSL stood 450. Okay, that looks fine. I wonder if did I mess something up here? No, this is just doing vert byte code, which we're getting here. I wonder if I forgot to take something out of here when I was showing it. No. Yep, that looks fine. This was working before too, wasn't it? Did I just not compile these correctly or something? So we got main. We have main. If I compile, looks like we're fine there. We get our output. Let's run this again. Maybe this was never working. I thought I remembered this working though. Oh, I'm an idiot. If not result, this should be if result does not equal VK success. Okay, let's try this again. So it was probably fine. Okay, good. That's good. It is fine. I just need to actually code. Easier said than done. All right, so we destroyed the pipeline layout, which I did write VK destroy pipeline. Okay, cool. So we are doing that. It ran fine. We had no errors. That's it. Now we go on to render passes and then conclusion. Oh, and thank God, render passes is shorter, so maybe we can finish this. Oh no, conclusion. Why does he have code in conclusion? Conclusion should just be like text, right? Okay, so before we can finish creating the pipeline, we need to tell Vulkan about the frame buffer attachments that will be used while rendering. We need to specify how many color and depth buffers, how many samples, how their content should be handled. All of this information is wrapped in a render pass. All right, so let's create a render pass. Do we actually call create pipeline? I'm interested. Do we? What did I call it? Okay, we do. Create graphics pipeline is what I called it. Static void create render pass. Let's go here, there. Okay. And we should also put that before we create the graphics pipeline. Okay, interesting. I wonder why he decided to put it there instead of, like, why he decided to do the tutorial with that before this. Okay. Attachment description. In our case, we'll have just a single color buffer represented by one of the images. Well, that's easy. Let's just go down there. This will just have an attachment description. I guess color attachment, is that what he calls it? Yeah, color attachment. Makes more sense. So we do that. Format is the swap chain image format, and the samples is 1 bit. I do like that. Simple. Swap chain image format. Samples is VK sample 1 bit. The format of the color attachment should match the format of the swap chain images. We're not doing anything multi-sampling, so we'll stick to 1. The load op and store op determine what to do with the data in the attachment before rendering and after rendering. We have the following choices for load. Load, clear, and don't care. If this was me, I'd probably just do don't care. Existing contents aren't defined. We don't care about them. Preserve the existing contents, clear the values. Okay, so when we load it, we're clearing it, and when we store it, or when we store it, we're storing it. Rendered contents will be stored in memory and can be read later. Okay, so gotcha. Okay. Anyway, so let's set the load op and the store op. Equals load op. What would we call that? Clear. And store op is store op store. Alrighty. We're interested in seeing the rendered triangle on the screen, so we're going with store. Yes, because we want to save it. I guess this is useful for like pass-through frame buffers or something. Like maybe, yeah, I've got no idea. Okay, anyways, the load op and store op apply to color and depth data. Wait, okay, and then what does he do? Yeah, so why does he do this? Stencil load. Oh, stencil load op. I was very confused for a second. So this is a different load operation. So we don't care about the stencil. Makes sense. Stencil load op equals don't care. Store equals don't care. And textures and frame buffers are represented by VK image objects with a certain pixel format. However, the layout of the pixels can be changed based on what you're trying to do. So some of the most common layouts are optimal, which uses images used as color attachment, source images to present it in the swap chain, and transfer images used as a destination for a copy operation. We'll discuss this topic in more depth in the texturing chapter, but what's important is the images need to be transitioned to specific layouts that are suitable for the operation. The initial layout specifies what it is before, and the final is what it automatically transitions to when it finishes. Undefined for initial layout means that we don't care. The caveat is the value that the contents of the image are not guaranteed to be preserved, but that doesn't matter since we're going to clear it anyways. We want the image to be ready for presentation, which is why we use present as final layout. Okay. Interesting. So much information. Okay. So the initial is don't care. I don't think that's exactly. I think it was undefined. Yeah. Image layout undefined. Okay. And then color attachment. Dot final layout equals layout. What was it? It was like layout present. Yeah, that's what we want. Present source KHR. Subpasses and attachment references. A single render pass can consist of multiple subpasses. Subpasses are subsequent rendering operations that depend on the contents from the previous passes. Yep, post-processing. Deferred rendering, I'm guessing. Every subpass references one or more of the attachments that we've described using the structures in the previous sections. These are attachment reference structs that look like this. The attachment parameter specifies which attachment. Okay. Layout specifies the layout. Vulkan will automatically transition the attachment to this layout when it's started. We intend to use the attachment. Okay. Layout will give us the best performance as its name implies. Vulkan may also compute subpasses in the future, so we have to be explicit about this being a graphic subpass. Next, we specify the reference color attachment. Okay, so we have a color attachment reference. That tells us which attachment we're referencing. And then we have the description. Okay, so many things. Okay, let's go ahead and do this. Voxrips, you seem to have decided you're going to render that triangle today, huh? No. I don't think we're getting there yet. There's still all this stuff. Oh man, it just makes me sad looking at that. This is like, what, 6 hours in the combined stream times, because I've only done this while streaming. 6 hours in, and we're still like so far away from doing a triangle. Probably 7 hours, because these have been like 2.5 hour long streams. Not cool. Not cool. In my opinion. I'm also curious too, like this tutorial is written in a style that assumes you're not familiar with any graphic stuff. I am really curious how many people are following this tutorial that have zero experience with graphics APIs at all. Because that would be like, if I had zero experience with OpenGL and I was just trying to follow this, I would have given up at like here. I would have been like, what am I doing all this garbage for? Like, yeah, so I'm kind of wondering if his need to explain all of this stuff is really necessary at the detail that he is explaining it. Because I highly doubt that there's a lot of people following this who are like, I've never used a graphics API. Let me start with Vulkan. But maybe there are. I don't know. I could be wrong about that. Yeah, I am interested. So I guess we're just saying that this is attachment 0, and then we give it the layout, which is our pipeline layout. Yeah. No, that's not. What is this? Oh, an image layout. Ah, okay. VK image layout color attachment optimal. Yeah. Alrighty. And then the subpass is described using a subpass description. Okay, so it may want to, support compute subpasses. That's why we have to, okay. So we're basically saying this is for graphics, not compute. VK subpass description. Oh man, I keep hitting that bracket. I think that's like the 6th or 7th time I've done that this stream. It's very annoying. Okay. Pipeline bind point is graphics. What was that exactly? Pipeline bind point graphics. Okay. And then we have more stuff. Voxrips, the first article has someone asking whether this is a good tutorial to learn CPP on Vulkan at once, and they don't have other graphics API experience. So at least one. That's a scary place to be coming from. I would not want to be that person. Man, I remember just learning OpenGL, and I was like, what is all this garbage? Like, coming from Java AWT and like HTML canvas, I was like, I just want to draw a pixel. Why is this so hard? But interesting. So we have one, and I'm guessing we're going to give it, for our color attachments, we are just going to give it a reference to that guy. Maybe our reference to, is it? Yeah, okay, I guess we're giving it our reference, a reference to our reference. The index of the color attachment in this array is directly referenced in the fragment shader here. The following other types of attachments can be referenced by subpass. Input attachments that are read from the shader, resolve attachments, multi-sampling, depth stencil, and preserve. Okay, so that's interesting. So this is talking about that. Interesting. Very, very, very verbose. After trying Vulkan, OpenGL seems like literally nothing, honestly. Yeah, I am agreeing with you wholeheartedly there. Okay, the render pass. I'm curious real quickly. How long is this so far? So yeah, we're at 888 lines of code so far, just for a triangle. Man. Thank you, Epic Games. Cool. So now that the attachment and basic subpasses referencing it have been described, we can create the render pass itself. Create a new class member variable to hold the VK render pass object right above the pipeline layout variable. So we need another thing for our render pass. One interesting thing, I think I said this at the beginning of the stream too, but I've been toying around with the idea of learning 6502 assembly and coding some sort of emulator and possibly a few games in assembly, because I think it'd be cool. And one interesting thing about that is, like, back in the day, in order to draw stuff to the screen, you basically just had some like region of memory, right? Where you just had some memory that started at like whatever the address was. And this was just your graphics memory, right? And to draw to the screen, all you had to do was say like, hey, set this to be like FF. And that's your however many bits that define the color for this specific pixel in the screen. It's amazing the hoops you have to jump through now to get to that same point. Whereas 40 years ago, 50 years ago, I don't know how long, you could just say like, hey, change this memory. I just want to put a pixel there. So yeah, I wonder how much more difficult it's going to be for people to get started doing this stuff 20 years from now. If already like we've gotten to such a high level of abstraction that it's like, there's no way you're going to be able to tell like how exactly does that pixel get put into memory on the graphics card and then eventually make its way to my device's screen. Like, we've just, yeah, lots of abstractions. Chico Ferreira. Ken Relly also coming from Java and started learning OpenGL last week. Yes. Okay, so the render pass object can be created by filling in the render pass create info structure with an array of attachments and subpasses. The attachment reference objects reference attachments using the indices of the array. Okay. Oh, cool. We're at the end of this. Oh, that makes me so happy. VK render pass create info. Render pass create info. Again, that's like what? 10? I don't know. Render pass create info dot s type equals VK structure type render pass create info. Cool. And then we've got the attachment count and the subpass count. Attachment count is 1. We've got attachments is, at least they're consistent. Like, it's really easy to start picking this stuff up since they are so consistent with their naming schemes and everything. Attachment count, and then our subpass count is also 1. and we'll give that our subpass. We should be good. We should be good. And then we want our result. Create render pass. Give it our logical device, our create info, our allocator, and our render pass. We will fail here. And we're good. That's it. That's our render pass. And we need to destroy the render pass after we destroy the pipeline layout. Okay, and then we connect them together in the next thing. So we're just about there. Destroy graphics. VK destroy pipeline. There we go. Okay, we'll give it our render pass and no pointer. All right. Drawing one pixel might have been easier, but anything more abstract and advanced is way harder. Yep. And there isn't exactly a specific buffer now, but you still have the ability to create one for a window, I mean. Yeah, and that's true too, but still, like, I mean, I don't know. I guess they still had abstractions back then too, because I don't think you would write directly into the memory on the device that was displaying it. Like, I don't know. So if you would have written to that pixel to that buffer, right, that contained all the pixels for the monitor, were you writing directly into the monitor's video RAM, or were you writing to some card on your PC and then that data was transferred to the monitor, you know, so many times per second? So yeah, I wonder how much abstraction they had even back then, where it's like technically you're writing directly to the buffer, but like that buffer, you're not following that pixel all the way to the monitor. Like you're still getting some abstraction from your drivers and stuff, which is interesting. So like there's still even more layers between that, which is it's just crazy how much stuff goes into like putting a pixel on the screen. And especially like once you get to high density display layouts, right? High density, what is it? DPI, display density pixel info or something like that. I don't know. But it's basically like you have multiple pixels comprising of one pixel because, you know, 4K screen, you're not actually going to show all 4K pixels and you're going to abstract that. It's all sorts of crazy stuff, like on phones specifically. I think monitors can actually display the full range of pixels, but with your phone especially, you're going to have like multiple pixels compressed into one smaller area. Yeah, let's go ahead and get this conclusion done. We are almost there. Almost there. Okay, we can now combine all the structures and objects from the previous chapters to create the pipeline. Finally, we have the shader stages, we have the fixed function states, we have the pipeline layout, and we have the render pass. And we can combine all of these into the graphics pipeline create info. But before the calls to the destroy shader module, because these are, okay, yeah. So, we never did that in create graphics pipeline. Oh yeah, I guess I didn't even realize that. We never really created the graphics pipeline create info. Their verbose naming scheme is contagious, apparently, because now my variable names are getting super long, too. Structure type graphics pipeline create info. And that is correct, right? That is correct. Okay. Yeah, let's just, we'll call this pipeline info. But would that, no, okay, we're keeping it that way. So we have two stages, and then we're going to give it the shader stages. So pipeline create stages 2 p stages equals, and we've got that right up there somewhere. What was it? That was pretty far up. Shader stages. Okay. So we give it those stages. Then we have the input state, assembly, viewport, rasterization, multi-sample, depth stencil, color blend, and dynamic state. All of that stuff, except I didn't do dynamic state. So I wonder if I can just leave that null. Because the viewport, I just left that. I guess maybe I should do the dynamic state. Yeah, I probably should make that dynamic. Okay, let's do that real quick. Let's go back a little bit and make that dynamic, which I should have done in the beginning, but I didn't want to. Okay, that's in the fixed functions. Let's see, viewport scissors. I think that's right there. Actually, no, dynamic state's up at the top, right here. But he talks about it again, yeah, right here. So do I have that viewport state? No, I do not. I probably needed that too, and I just completely skipped it. Okay, let's add these things. So our dynamic states, stood vector of vk dynamic state that's not what I wanted to do. Okay, let's do that. We've got viewport and scissor. I'm sure he's keeping this as a vector for some reason, but we're just gonna do that because it's a little bit easier. Okay, we got that. Create info. Okay, dynamic state info dot s type equals vk structure type. What is that? Pipeline dynamic state create info. Let's see. We've got p dynamic states, which equals that. And then we've got count, which is 2. I don't think those things are important. No. Okay, cool. And then you only need to specify their count at pipeline creation time. Okay, so then we got the viewport state, which I never really did. Viewport state create info. Okay. And that's going to be structure type pipeline create viewport state info. What is it? Create viewport state create info. Okay, just make sure that's right. Yep. Okay, and then we just say we have one viewport, one scissor. Viewport count is 1. Scissor count is 1. Okay, let me just check chat real quick. Sorry. Why the heck is dynamic states a vector? Great timing. Yeah, I was wondering the same thing. Not sure why they did that, but I'm guessing it's because in the future they're probably going to have it return a vector or something, and they just, instead of, they probably wrote all this code up front and then started just like left those types of things in there. Yeah. I have viewport state create info already. Oh, thank you for letting me know. I did not realize that. Do I have that? Yeah. How did I not see that? That is exactly the same. And I just completely, okay. So that's, thank you for pointing that out. I don't know how so I had the dynamic state stuff there. Wait a second. Wait. No, so that's there. Oh, okay. So this is what I had already. Thank you. Yes. Okay. So that's what I had already. This we do need. Almost deleted the wrong thing there for a second. Yeah. Okay. Cool. So now we're back here. So we have our vertex input state, input assembly state. Let's just go through this line by line. Pipeline, create info. Oh, come on. Let's just do this. Yeah, that's good. So vertex input state. Yeah, info. No. Oh, pointer. We got that. We have the input assembly viewport state. So input assembly. Okay. Oh, wait, that's the same thing. Input assembly. What did I call that? I must have called it something different. Assembly state info. Let's call it that, just to be consistent. Okay, that's good. So we got that. Viewport state and the rasterizer. Okay, we got that. Got that. Rasterizer, which I believe I called raster info. All right. Multi-sample. That was the stencil. Yeah, depth stencil, which null pointer. Color blend, dynamic state. Color blend, which color blend info. Oh, just blend info. And then we have, what was that last one? I cannot think. I am like done. Dynamic state. Like my brain is just broken right now, guys. Okay, and that is dynamic state info. Okay, we are almost there. Then we reference all of the structures describing the fixed function stage. Pipeline layout is pipeline layout. What? Okay, no, I'm missing something here. Pipeline info.layout is pipeline layout. Oh, that makes sense. What file format is the easiest editor to make? TXT. It's got to be the easiest, right? Just the TXT format. Nothing to do there. After that comes that, and then, which is a Vulkan handle rather than a struct pointer. Wait, okay. So that pipeline layout. Okay, and finally we have the reference to the render pass and the index of the subpass. Render pass and subpass. Man, if we get to the triangle and there's no triangle, I do not even know where to begin debugging this. I think I'm just going to cry if that happens. So let's hope we get a triangle up when we finally get to the triangle stage. Yeah, because I don't know what we're going to do if there's no triangle there. Render pass. Render, what was it? Subpass equals 0. Yeah. And Voxros, I honestly don't know. Text editors are hard. Yeah, I mean, if you're gonna, what file format has the easiest editor to make? Yeah, I don't know. Maybe you could do something. So I know you're talking about the handmade jam, right? And Tanner 440, if you don't get a triangle, try render doc probably. Yeah, that's what I would do initially, but if it doesn't work, it's gonna be a very sad moment. But also Voxtros for the handmade jam. I know one thing that I encounter daily, and I saw something for this and I was like, oh, that's really cool. But then it didn't work quite the way I thought. I don't know about you guys, but often I'll have stuff where I serialize things to binary, right? So I'll have something where I'm like, okay, I have like my animation state, which is a U8 and it maps to like these states, you know, like state 0, state 1. And then after that in the binary, what I have is like the animation start, which is a float 32, and then I have animation end, which is whatever, right? F32, so on and so forth, ... And so basically what this thing was it was a visualizer. So you could basically you could describe your data like in some sort of language format. And it might not have been exactly like this, but basically you describe it, you say exactly what type it is, what the variable name is and everything. You give it to this thing, and the thing basically generated like C++ code that would automatically serialize, deserialize for you. And then it would also, if you gave it the file that matched this format, then it would also give you like a display so that you could see the names and stuff. So you could just like double click the binary file and then look at it. Anyways, I don't know what I'm trying to say here, Voxriffs. I think this would be really cool. I don't think this is doable in a week though, now that I'm thinking about it. But I think this is a really cool tool that would be awesome to see somebody create. But yeah. You talking about the text editor and stuff, it just kind of got me thinking along those lines because I do a lot of binary serialization these days. And I don't really worry about the text editor type stuff anymore. Okay. There are actually two more parameters, base pipeline handle, which we're going to do null, and base pipeline index. Vulkan allows you to create a new graphics pipeline by deriving from an existing pipeline. Pipeline derivatives is that it's less expensive to set up pipelines when they have much functionality in common with an existing pipeline, and switching between them can be done quicker. Right now there's only a single pipeline, so we just null and invalid index. These values are only used if the create derivative bit flag is specified. Okay, we are almost there. So let's do that. Base pipeline handle. That is -1. Voxers, I had a pitch for the handmade jam, so honestly definitely fits with the theme. Let's see. I'll have to click on that later on my phone or something so I can actually see it. But I'd be interested in seeing the pitch. I literally just left that Discord because I was spending too much time in there. So bad timing, I guess. Now we can prepare for the final step by creating a class member to hold the pipeline object. Finally. Okay, so then we can finally go up here and say static VK pipeline. Right, there we go. And I am guessing I know exactly what's going to happen. We're going to say result equals create pipeline cache. Okay, maybe we're creating a pipeline cache. No, create graphics pipelines. I was close. Okay, VK create graphics pipelines. So we give it our device, our cache, which is null. Okay, makes sense. Our info count, we have 1. Create info. Null. Pipelines. Pipeline, which is just our pipeline. All right, and then if not, or result that, then failed to create graphics pipeline. All right. And Voxriffs, it's on the Games with Gabe Discord. Oh, is it? I should have been able to see that then. I'm gonna have to look a little bit later because I'm not seeing it in here either. Weird. Oh, no, I think, oh, I know what you're talking about. It's just the pitch that, yeah, I got you. I do remember when you were talking about that earlier. And I think I remember seeing it. I might have left commentary or not. If I didn't leave commentary, it's probably because I was like, oh yeah, I agree with whatever you were saying. VK create graphics pipelines function actually has more parameters. It's designed to take multiple. Yep. A second parameter is the null handle. Okay. Graphics pipeline is required for all common drawing operations, so it should only be destroyed at the end of the program. Okay, this is the final thing. Now running your program, and we should have a pipeline. So, free VK destroy pipeline, logical device, graphics pipeline, null pointer. And does it run? No. Am I missing a semicolon or something? No, I'm just reusing result. Okay. Well, that's simple. We can just do that. Okay. Oh no, it's not working. Did I do something stupid? Probably. Oh, okay, here we go. Validation layer works. That's good. Vulkan pane. No entry. Oh, okay. No entry point found named Vulkan pane. I forgot about this. So earlier we had changed our entry point names, but it didn't work quite right. So we had to change them back to main. But it was going to be tree and Vulkan pane, and it was complaining about that. But it looks like that should fix it, hopefully. Okay, cool. And that worked. That fixed it up. So simple to fix that, and no errors on exit. Awesome. I am happy with that. We'll take that. It was quite a day. So let's, yeah, I only modified 2 files, but it felt like a lot more. Create the graphics pipeline. Push. Alrighty. And with that, I am going to close out here in a minute. I am curious what you guys are thinking, though. I started looking at, yeah. So I started looking at this. This is like a 6502 tutorial, and then it ends with creating a snake game, which is interesting. So they have like a little 6502 emulator here. And I was interested in like creating like a little playground type thing. I am on the home stretch now. We're almost there. Next week we will finish this and we'll have a triangle, hopefully. But I'm interested in kind of doing like a Pico engine type thing. What's Pico 8? I am curious because I've never really looked into the constraints and stuff that they have. Like, yeah, they kind of force you to code in their thing, which I don't really like. But it is cool. But basically, it's kind of like a Pico 8 idea, except it'd be like an emulator with some debug stats and everything for 6502, with maybe some extra special code to help you do like input from like consoles and stuff, which would be cool. But basically, it would just create like a window, do a lot of input handling and everything for you, and then give you an interface that's similar to what you would have gotten back in the day, and then it kind of blows up the pixels. Yeah, I'm just interested because, right, Super Mario, whoops, sorry about that. If that was super loud, sorry. But the original Super Mario Bros. Was coded in 6502 as far as I know. And I think it'd be really cool to like experiment with creating games in assembly like that. Small games, starting with Snake and then hopefully getting bigger from there. But I think that'd be a really fun projects and stuff to do in my spare time. Of course, once I get back to coding Minecraft and stuff. So once we get the math animation tool in better shape and everything, I think these would be fun streams to have and stuff. So I'll think about it. If you guys have any ideas or whatever, just let me know and think about that. But yeah, thank you for watching, everybody. We made a pipeline. Very exciting. Our window of nothing that we can't even resize. But hey, we've got a pipeline. So almost there. I hope you guys have a great day, and I will see you next week around the same time if you're able. Yeah. How far is it? How far is the tutorial? We've just got this stuff left for the tutorial. If you're talking about the math animation editor, yeah, okay. So I did that at the beginning of the stream, but we can take a look again real quickly. It is coming along nicely. Let's see. I've been doing some rejigging of the fonts and stuff. So they're not quite right now, but basically the fonts work better. It looks worse here, but they're using the same internal representation that all SVG objects are using, which is good. I've still got to work out a few more bugs and stuff, but it crashes less because I fixed a lot of the bugs and stuff, which is good. And so I've been working on getting that on there. This is UV problems. I have to calculate the bounding boxes better because it's not getting these quite right. And you'll also notice down here, which you cannot see, I really need to figure out a better way to handle, whoops. Okay. Let me move chat out of the way, or actually let me just do this. Yeah, okay. So you guys couldn't see this in the beginning either. But basically what you'll notice is down here, I have the texture, which is the SVG cache. And so you'll see that it kind of dynamically updates as this plays. So this is the texture that like all the SVG stuff is getting written to. And you can see that it like dynamically updates and all that. Eventually there will be multiple textures that when this runs out of room, like grows to another texture and stuff. But yeah, so this is like some of the improvements I've been working on. I just got to fix these, but it also means that I can do stuff in 3D. You can see that these circles are 2D circles, but they are being shown in 3D here. And they are truly 3D, like they're just quads. So like if I click that, I can kind of rotate it and you see that like it's got the proper transparency, all that stuff. Blending's working appropriately. If I turn that down a little bit more, you can kind of see how it blends with the background and stuff, and it should look appropriate. I guess I don't have scale working yet though. But yeah, so turned out pretty good. And once I get, so now that I have this working, I should be able to have 3D text too, which is kind of what the whole point of all this stuff was to get 3D text. So, and 3D latex. So that'll be good. Yeah. Turned out pretty good so far though. Anyways, guys, I'll see you next week around the same time and hope to see you there.